constant vector, x0 just some constant value. For example, one case might be x0 equal to 1, but you have many other cases. So if x is equal to 0, example, x0 equal to 1, then you have the vector 1, 1. So now I'm trying to compute what is the variance of this vector. Say, variance of y hat. What is y hat? Y hat is your prediction. It's your predicted value or your approximation. Let's see. What do you have? You have x transpose times x inverse. Sorry. Maybe I should start this here. Let's recall x is equal to x times beta plus this. Now I'm predicting y hat should be, x is not changed because x is just the constant, is your design value. But beta is beta hat. So I'm trying to compute what is the variance of y hat. Okay? Now, using the result, what we have done, we can compute that value, and which is, you just compute what is the variance of this. That would be equal to that one variance of, this hat quality bar, all right? So I'm using, in fact, a equal to 1, 1, so I can predict some value. For example, let me say the following. If we take, say, a equal to 1, 1, I'm looking at a transpose times x transpose times x transpose this, and times a sigma squared. Maybe I better send you the solution for the other problems you will get first. So in that case, I have 1, 1 here. This matrix, I know what that is. We did. That's 1/5. 1/10. You have to go back to your notes for that. And this part is 1, 1, and here is sigma squared. So I'm looking at a particular value. I can compute. In fact, if you run the calculation, you see this is the 0.3 sigma squared. So now, in particular, so if I want to compute what is my predicted value, the confidence interval at the point, say, a equal to 1, 1, the confidence interval will be equal to this. You have your y hat plus and minus t alpha over 2, and multiplied by the quantity. Here is, we don't have the sigma, so we use the s to denote that. And here I have a transpose x inverse times a. That's what you have for this. So if you plug in all the numbers, you get 1.7 plus and minus 0.78. So what is the predicted value? What I meant is this. So the meaning is this. If I take beta 0 at equal to 1, beta 1 equal to 0.7, x equal to x0 equal to 1, then what you have is y hat will be equal to 1 plus 0.7 times 1, which is equal to 1.7. So this is your predicted value at the particular point. The point corresponding to beta 0 equal to if you use the vector beta 0 equals 1, that's computed value, and then you are using your x is 1, 1, so you have this multiplication. And then you get this confidence interval. So always associate with some sort of calculation. I think I'll send you something about more on the confidence interval. You will see. I thought it would be